Okay guys, so welcome back. So this lesson we're going to talk about kinematic equations and how do we use them and what are the situations we use them for. Okay, so first we go back to year 11 physics and we've learned a concept which is distance equals speed times time. Okay, all right, so that equation, if you know the speed of an object, you know the time of the object, you time together, that will give you the distance of the object, right? And then vice versa, if you know distance, you know time, you can calculate speed. If you know distance and speed, you can calculate time. You just need to rearrange equation, right? But this equation have a certain criteria. When can we use it, okay? If I put speed over here, say the time is going to be 10 seconds, say time is 10 seconds, but the speed, let's say the speed is changing. So if you had, at the beginning of that 10 seconds is 2 meters, and then when it becomes 8 meters per second, well, what speed do you use? And obviously it's not fair for you to put 2 there or put 8 there, right? So then we can't use this situation anymore, okay? So when do we use this situation? We only use this situation, this equation only used for when the speed is a constant speed. If the speed don't change, we can use this equation. Or we say if it's the average speed. Okay, so be very careful. Lots of students this year, oh, speed, oh, I know speed, I know time, boom, put in there to calculate distance. But no, if it's not a constant speed situation, the speed they give you cannot be used for this, okay? All right, so but now what do we do? Well, we have a new set of equations. So these equations together I call the kinematic equations. And this equation, you also do not use it for all situations. Say, for example, if it's a constant speed, and then you don't need to use this equation, okay? When you use this set of equations, you use it when there is a constant acceleration. If it's a constant acceleration, and then you pick one of these equations, and then put it in the thing, okay? And these 4 equations will be given to you. And exactly why do we have these 4 equations? Like, we don't really need to know, okay? But they basically come from the simple concept. Say this one, say the initial speed and final speed divided by 2, that's your average speed. Then you have average speed times time to become your distance, okay? So this one is the change of, this is going to be change of speed. Acceleration times time, the change of speed. Change of speed at the original speed, they get the final speed. Okay, and there's a reason for that. I mean, these 2 equations, there's a reason behind that as well. So I don't want to spend too much time talking about that because you don't need it for your assessment. Okay, but if you're interested, and then you can Google it, say kinematic equation, derived kinematic equation. They will tell you, okay, where does this equation come from? Okay, all right. Now I'm just going to give you an example how to use this equation. There's some homework. So once you know the method, and then you can apply it. Okay, all right. So let's say this: if I have a box over here, I'm gonna push this box forward with a tension force. It's gonna equal to 100 Newton. Okay, and then I know there's going to be a friction, give me, and that's going to be 20 Newton. And then I tell you the box have a mass of, say, 10 kg. And the question is going to ask you, okay, the box is going to be pushed, and then it's going to reach over here. They give you a distance, and that's going to be 100 meters. Okay, so it's giving you 1, 2, 3, 4 information. And what is it going to ask you? It's going to ask you the time it takes. When is it going to reach the end? Okay, reach that 100 meters. Okay, I'll say here, 1, calculate the time it takes to reach 100 meters, and 2, calculate the speed, the final speed. Okay, so 1 is asking you time equal to what, and then the other one is asking you the final speed equals to what. Okay, so you can write this question down in your book as an example. Okay, all right, so now let's have a look. So friction and that, well, sometimes there's some hidden information. So for this question, we're going to say the object was stationary at the beginning. Okay, if it's stationary, there is a hidden information over here, which is the initial speed is going to equal to 0 meters per second. Okay, so this one they do not always tell you. So you look at the question and see if there is this hidden information there. Okay, all right, and then, well, we're going to use a little bit of information from last year. So first, can we use this equation? We have to figure out, well, whether it's going to be acceleration or no acceleration. So let's have a look. 100 Newton force going forward and the 20 Newton force friction going backwards. So according to Newton's law from last year, is the forces are unbalanced, right? If forces are balanced, stationary or constant speed, so then you can use this equation. But now force is unbalanced, so there's going to be an acceleration. Okay, so if I've got to calculate this acceleration because I know force and I know mass and I can calculate acceleration. Okay, so first step, what I'm going to do is I'm going to find the net force because the net force is going to tell me the acceleration. The net force is going to equal to the 100 Newton going forward minus the 20 Newton. That's going to give me 80 Newton. So that's my net force. Okay, and from the net force, now I can calculate acceleration. This net force is going to give me acceleration. We use the equation we've learned from last year, force equals ma. Okay, so now the force equals ma, we put the numbers in. 80 is going to equal to the mass, which is 10 kg, times acceleration. Rearrange equation. Now I've got acceleration equals to 8 meters per second squared. Okay. So far, I haven't even calculated the time it takes, but I've got acceleration. How do I know acceleration? Because I know force and mass, right? So that is the step you have to take to get there, okay? All right, so now the next step is, okay, so now I think I got a lot of information here. I got acceleration, I got initial speed, and ask me time. I got distance. Let me go choose the equation over here. Okay, so then you pick and choose which one you want to use. There are quite a few. This one might be able to use or can't use, and this one maybe can be used, not used. So and then you figure it out and find out, okay, this equation is the equation I can use. Okay, all right, so let's go with that one because I know distance. Distance equals to initial speed time plus half at squared. Okay, so let's see if we can use this one. Distance I know is 100 meters. That equals to the initial speed, which is 0, t we don't know, and plus half, that's 8, t squared. Okay, that has become 0. 100 equals to 4 t squared, and t equals to squared equals to 25, t equals to 5 seconds. Okay, so this way I find out, okay, t is going to equal to 5 seconds. Okay, so that's how you do it. You just go find the equation that has your numbers. How did I know? I want to find time, so I need an equation with time. And I know acceleration over here. And I know initial speed, vi. And I know distance. I just need to find the equation with these three quantities. I know this one, this one, this one. This one is a question mark. So equation with this 4 number, and I've got it, which is this one. Okay, all right. Actually, okay, so that's the only one. Okay, so that's question 1 answer. Okay, let's say question 2. I'm gonna write it over here. Say question 2 right now, what I want is I want to find the final speed. I go choose the equation. I know time now, and let's say here, can I use this equation? Final speed, I know initial speed is 0. I know acceleration, I know time. Yeah, that's it. So we just use this one. Vf is going to equal to initial speed at at equals to 0 at 8 multiplied 5. That gives me 40 meters per second. And that's it. That's going to be my answer. Okay? Or you can go have a look if there's any other equation. This equation will work, and this equation will work as well. Okay? So you just choose the equation that works for you. Okay? All right, so that's it. So over here, obviously, we are using 2 different things. So one thing is what we've learned here about the kinematic equation, the new thing we've learned, but we've also used the net force, which force equals ma to give you acceleration. Okay, that's something you need for this year as well. So if you forgot about it, go have a search on Google or YouTube about force acceleration. So that's Newton's 3 law of motion. So you can have a look. So hopefully you understand that. Okay. All right. So if you have any questions, let me know. There's homework. So just practice this part. So the first part of the homework talking about vectors addition and vector diagram. Don't worry too much about that. We'll come back to vector addition. So we're gonna be doing this one first. Okay. So just different teacher teaches that different topic, different order. So we'll do this one first. And then the next lesson will be based on this. Basically, just use this equation, but with a situation where you have gravity as the acceleration. Okay. All right. So that's it. Have a great day, guys. If there's any questions, send me an email, and I'll be on the other side of your email. Okay. All right. Bye.